back to this session. Today in this session, we will be solving more numericals, and let us see how we can solve each numerical. For this numerical, we need to find safe axial load. We need to find safe axial load by using Rankine's formula. Rankine's formula. Okay, now what are given? In the given we have a cast iron column, external diameter and internal diameter is given. So that means this cast iron here is a hollow circular section. Okay, so external diameter D is given equal to 100 mm and internal diameter small d is given equal to 80 mm. Length of the diameter is given, L is given equal to 2 meter long, and the condition for this fixed end condition for this cast iron column is that fixed at one end and hinged at other. So it is fixed at one end and hinged at other end. Okay, this is the condition. Now we need to calculate the safe axial load, and the factor of safety is given. Factor of safety is given equal to 3. Okay, now let us first write Rankine's formula. So the crippling load by Rankine's formula is given by PR is equal to F of C into area divided by 1 plus alpha into LE by K the whole square. Okay, so this is the Rankine's crippling load formula. Now from here again the value of FC and alpha is given. So how much is given? F of C is given from the question, it is given equal to sigma C is given equal to 550 Newton per mm square, and Rankine's constant alpha is given equal to 1 by 1600. So these are all the given values. I have noted down the formula also. Now let us start by finding the effective length LE. Okay, the condition is given one end fixed and other end hinged. So for one end fixed and other end hinged, effective length LE is equal to L by root 2, which will be equal to length is given equal to 2 meters. So 2 divided by root 2, you will get 1.4142 meter. Now if you convert this into mm, multiply it with 1000, and you get 1414.2 mm. So this is the effective length. Now let's find area. Since this is a hollow circular section, area will be equal to pi by 4 d square minus small d square. So from here you get pi by 4. External diameter is given equal to 100, internal 80. So 100 square minus 80 square, you will get area equal to 2827.433 mm square. So this is the area. Okay, now let us find the value of K here. Okay, so K will be equal to root over of I minimum by area, right? So how much is radius of gyration for a hollow rectangular section? It will be pi by 4 d raised to power 4, pi by 64, pi by 64 d raised to power 4 minus small d raised to power 4 divided by area. Okay, so from here it will be equal to pi by 64 d, capital D is 100 raised to power 4 minus 80 raised to power 4 divided by area is 2827.433. so from here you get the value of K equals to 32.0156 mm. Okay, so this is the value of K. Now we have found value of LE also, K also, area we know, FC alpha is given. So if we put all in this Rankine's formula, PR will be getting FC is given equal 550, right? So we have 550 into area we found 2827.433 divided by 1 plus alpha is given equal to 1 by 1600 into LE. How much did we find? LE is equals to 1414.2 divided by the K we got equal to 32.0156 the whole square. Now if you solve this, PR we will be getting equal to 700,647.96 Newton. Now if you convert this into kilonewton, it will be 700.65 kilonewton. Okay, now from here if you find the safe load will be equal to Rankine's crippling load divided by factor of safety. Okay, so this will be equal to 700.65 divided by 3 and we get 233.55 kilonewton. Okay, so this is the safe load. So I hope this numerical is clear. Let us solve the second numerical for today's session. Determine Rankine's crippling load for a hollow circular column of external diameter 80 mm and 15 mm thick. It is 3 meter long with both ends fixed. Take sigma c equals to 500 Newton per mm square and Rankine's constant alpha equals to 1 by 1600. So let us get started with this numerical also. Now for this numerical we only need to find the Rankine's crippling load. So we only need to find crippling load by using Rankine's formula. So Rankine's crippling load P we need to find for a hollow circular CI column of external diameter. So external diameter is given equal to 80 mm and the thickness is given, T is given 15 mm thick. Okay, so from this thickness we can find the internal diameter. So let's find it right now. Internal diameter small d will be equal to, this external diameter is capital D, right? So d minus 2t will get internal diameter, right? So it will be equal to capital D is 80 minus 2 into 15. So from here you get equal to 50 mm internal diameter. Okay, what else is given? It is given length. L is given equal to 3 meter long with both ends fixed. Now the condition is that both ends are fixed. So if both ends are fixed, LE will be equal to L by 2 for both ends fixed, right? So this will be equal to 3 by 2, which will be equal to 1.5 meter, and this will be equal to 1.5 into 10 raised to power 3 mm. So we found the effective length also. And what else is given? Sigma c, which is equal to Fc, is given equal to 500 Newton per mm square, and value of alpha is given equal to 1 by 1600. Now by using the Rankine's formula, let us find the value of P. So before we find the value of P, we need to find moment of inertia, area, and radius of gyration, right? So let us first find area. Okay, so area A will be equal to pi by 4 d square minus small d square. So this will be equal to pi by 4. Capital D is equals to 80 minus small d is equals to 50 square. So from here area will be equal to 3063.05 mm square. Okay, this is the area. Now if I find K will be equal to K minimum. Okay, this is K minimum, here will be equal to I minimum by area. So how much will be I minimum? It will be equal to pi by 64 d raised to power 4 minus small d raised to power 4. This is moment of inertia about x-axis divided by area. Now from here I get equal to pi by 64 into d, capital D is 80 raised to power 4 minus small d is 50 raised to power 4 divided by area is 3063.05. Okay, now from here K minimum will be coming equal to, it will be coming equal to 23.58 mm. Okay, so let us put it in a Rankine's formula. So crippling load by Rankine's formula is given by formula is equal to PR is equals to Fc into A divided by 1 plus alpha Le by K the whole square, right? So from here F of C is equal to 500 into area is 3063.05 divided by 1 plus alpha is given 1 by 1600 into LE. LE is given 1.5 into 10 raised to power 3 divided by K is 23.58 the whole square. Okay, so from here we get the value of PR will come equal to 477,245.75 Newton. Now if you convert this to kilonewton, you have to divide by 1000, which will be equal to 477.245 kilonewton. So this is the Rankine's crippling load. Okay, so we found it. This is the end of this numerical. So I hope this numerical is clear also. Coming to the third numerical of the session, it says determine Rankine's formula and safe load on the column of 5.5 meter length with both ends fixed can carry a factor of safety 4. The properties of sections are area 1777 mm square, Ixx equals to 11.6 into 10 raised to power 6 mm raised to power 4. Moment of inertia about y-axis is equals to 0.84 into 10 raised to power 6 mm raised to power 4. FC is given equal to 320 Newton per mm square. Alpha, which is Rankine's constant, is given 1 by 7,500. So let us get started with this numerical also. Now in this numerical we need to determine safe load by using Rankine's formula. Okay, so we need to determine safe load by using Rankine's formula. Okay, and for the same let us write down what are the given. So the length of the column is given, L is given equal to 5.5 meter long, and it says both ends are fixed. So the condition is both ends are fixed. Now for this, effective length LE will be equal to L by 2, which will be equal to 5.5 divided by 2 will be equal to 2.75 meter, which will be equal to 2750 mm, right? And next, what is given, it can carry with a factor of safety of 4. So factor of safety is given 4, and the properties of sections are area is given equal to 1777 mm square, and moment of inertia about x-axis is given 11.6 into 10 raised to power 6 mm raised to power 4. And what else is given? Iyy is also given equal to 0.84 into 10 raised to power 6 mm raised to power 4. F of C is given equal to 320 Newton per mm square, and Rankine's constant is given equal to 1 by 7500. So these are given in the question. Now let us first find area, right? No, we don't need to find area is already given. Then what else do we need to find? We don't need to find moment of inertia also. Now before we take which moment of inertia to take, now यहाँ पर IXX भी दिया है, IYY भी दिया है, कौन सी लेंगे? अब ये दोनों से जो भी कम है वो लेंगे. Okay, minimum. So IYY is coming minimum here, so we will take IYY this value, और ये IXX का value हम नहीं लेंगे. Okay, and what else do we need to find? There's nothing. So let's first find radius of gyration. Okay, K minimum will be equal to I minimum by area. So I minimum is along IYY axis. So 0.84 into 10 raised to power 6 divided by area. Okay, so from here you'll get here the area. I did not replace, it will be 1777. Okay, area 1777. So from here you will be getting value equal to 21.74 mm. So this is the radius of gyration. Now let us put in a crippling load. Formula is given by PR is equals to F of C into area divided by 1 plus alpha LE by K the whole square. यही है, right? So from here PR will be equal to F of C कितना दिया है? 320 into area 1777 divided by 1 plus constant, Rankine's constant is given equal to 1 by 7500 into LE कितना मिला? LE 2 2750 divided by K came equal to 21.74 the whole square. Yeah, now from here PR will be coming equal to 1.813 into 10 raised to power 5 Newton. Now if you convert this Newton to kilonewton, it will be equal to 1.813 into 10 raised to power 5 divided by 10 raised to power 3. So from here you will get cancel, here it will be 2. So 1.818 into 100 will be equal to 181.3 kilonewton. Okay, now from here we need to find safe load. So safe load will be equal to PR by factor of safety. So we got 181.3, and factor of safety, how much is given? It is given 4. Factor of safety 4 divided by 4. So from here you get 45.32 kilonewton. Okay, so I hope this numerical is also clear. This is the last numerical for this session and also the last numerical for this unit. Okay, let us get started. A hollow circular column 6 meter long has to transmit a load of 800 kilonewton. Using Rankine's formula and factor of safety 4, design a suitable section if both ends of the column are fixed. Take internal diameter equals to 0.8 into external diameter. FC is given equal to 550 megapascal. Rankine's constant alpha is given equal to 1 by 1600. So let us get started. Now for this numerical we need to design a suitable section. Okay, so it is a hollow circular section, and for this section we need to design its section. So that means the diameters are not given, right? So let us first start by whatever is given. So given in the question is that length of this hollow circular section is given, L is given equal to 6 meter, and what else is given? Load. So the safe load is given equal to 800 kilonewton. So if you convert this into Newton, it will be 800 into 10 raised to power 3 Newton. So even if you convert this 6 meter to mm, it will be 6 into 10 raised to power 3 mm. Okay, so what else is given? Using Rankine's formula and factor of safety of 4. So factor of safety is given. Factor of safety is given equal to 4. Design a suitable section if both ends of the column are fixed. Now it says both ends of the column are fixed. If both ends are fixed, so effective length LE will be equal to L by 2, which will be equal to 6 into 10 raised to power 3 divided by 2, which will come equal to 3 into 10 raised to power 3 mm. So this is the effective length. Okay, so what else can we find? Take internal diameter. So small d, internal diameter equal to 0.8 times the external diameter times the external diameter. So from here what we can say, let small d be internal diameter and d be external diameter. Okay, and what else is given again? F of C is given equal to 550 megapascal. Okay, which is equal to 550 into 550 Newton per mm square, and value of alpha, which is Rankine's constant, is given 1 by 1600. Okay, and now let us find the area. we need to find d here. Okay, we need to find d here. So let's see how we can find this d. So let us find the area of this hollow circular section. Area A will be equal to pi by 4 d square minus small d square. So from here we'll get pi by 4. Since we do not know d, capital D, we do not know external diameter, let it be d square only, and small d is equals to 0.8 times d square. So 0.8 times d square. Okay, so from here, after solving this, you will get value equal to 0.28 d square. Okay, first solve this portion, and then after solving it, cancel it with this. I hope you will know how to solve it. First solve this one, 0.8 d whole square. Okay, then minus it with this and then multiply here, then you will get exactly equal to 0.28 d square. Now next, let us find I, moment of inertia I. I will be equal to pi by 64 d raised to power 4 minus small d raised to power 4. This will also be equal to pi by 64 d raised to power 4 will remain as it is, and d is equals to 0.8 d raised to power 4. Okay, now for this I'll show you how to solve it one by one. Here you will get pi by 64 d raised to power 4 minus, if you solve this one, 0.8 raised to power 4 will be equal to 0.4096, and this d will also have a power, d raised to power 4. Now deduct from here. Since there is only d raised to power 4, consider that there is 1 here. Okay, so 1 minus this value, pi by 64 into 0.5904 d raised to power 4. You will get this. Now multiply this value with phi here and then divide it by 64. So I'm getting this value equal to, after solving this, I'm getting equal to 0.02898 d raised to power 4. So this is the moment of inertia. So solve this area also in the similar manner. Okay, and now let us find K. Now K will be equal to, since अगर हमने K फाइंड किया तो रूट ओवर यहाँ पर लगाना पड़ेगा, बट फॉर नाउ जब हमने मोमेंट ऑफ इनर्शिया एंड एरिया फाइंड किया तो एरिया पे भी d, वी डू नॉट नो द वैल्यू ऑफ d, सो लेट अस इंस्टेड ऑफ फाइंडिंग K, लेट अस फाइंड K स्क्वायर. So K square will be equal to I by A. The moment of inertia we got equal to 0.02898 d raised to power 4 divided by area, we got 0.28 d square. Now from here if you cancel it, you will get d square, and from here you will get this value equal to 0.1035 d raised to power square. So this is K square. Now we know that safe load is equals to P divided by the factor of safety. Now if you want to find this crippling load P, so P will be equal to, if we cross multiply it, P will be equal to safe load into factor of safety. Now safe load is given equal to 800 into 10 raised to power 3, 800 into 10 raised to power 3 into factor of safety is given equal to 4. So from here you get crippling load equal to 3200 into 10 raised to power 3 Newton. So this is the crippling load here. Now if you put all this value in a Rankine's formula, P equals to F of C into area divided by 1 plus A LE by K square. So if you put it in here, you will get P, we got 3200 into 10 raised to power 3 equals to F of C is equal to here 550 into area is 0.28 D square divided by 1 plus alpha value is given 1 by 1600 into, now L is given, so now हम यहाँ पर LE by L square ले नहीं सकते क्योंकि LE by K square ले नहीं सकते, because K square का हमने डायरेक्टली K square का वैल्यू फाइंड किया है, तो फिर यहाँ पर सिर्फ LE का ही स्क्वायर करना पड़ेगा. सो LE वी गॉट 3 into 10 raised to power 3, इसका ही स्क्वायर करना पड़ेगा, स्क्वायर divided by K square is equal to 0.1035 d raised to power 2. Okay, so this is how you will write. Now if you multiply these two value, you will get equal to 3200 into 10 raised to power 3 equals to 550. Let me multiply this also. 550 into 0.28 you will get equal to 154 d raised to power 2 divided by 1 plus. Now if you multiply all this thing, you will be getting equal to 54347.83 divided by d square. This is what you will get. Okay, and now let us solve for this portion. अगर हम इतना को सॉल्व करते हैं, बिकॉज यहाँ पर डिनोमिनेटर डी स्क्वायर लेके गया. नाउ आई विल सॉल्व ओनली फॉर दिस पोर्शन हियर. ओके, इक्वल टू 154 डी रेज़ टू पावर 2 डिवाइडेड बाय, ना डिनोमिनेटर पे डी स्क्वायर लूँगी. अब इसका डिनोमिनेटर पे भी डी स्क्वायर आने के लिए लेट अस इमेजिन देयर इज 1 इंटू डी स्क्वायर, ऊपर भी डी स्क्वायर होगा. सो आई विल गेट डी स्क्वायर प्लस 5434.7.83. right? Now I'll equate it again. 3200 into 10 raised to power 3 will be equal to, now यहाँ से अगर मैंने ये d को ऊपर भेज दिया तो it will be 154 d square into d square, ये इसको ऊपर भेज दिया, divided by remaining is d square plus 54347.83. this will be remaining, right? If you further solve this, you will get 3200 into 10 raised to power 3 equals to, here it will be 1.5. Instead of this, I'll just do cross multiplication. If you cross multiply it now, it will be 3200 into 10 raised to power 3 into this value d square plus 54347.83 equal to 154 times d square into d square will be d raised to power 4. Now let us solve this one. If you multiply 3200 into 10 raised to power 3 into d square, you will get 3200 into 10 raised to power 3 d square plus this value into this, you will get equal to 1.739 into 10 raised to power 11 will be equal to 154 d raised to power 4. Okay, now I'll send all this value to the left hand side direction. So if I send it there, it will change the sign. So what I'll get 154 d raised to power 4 this I'm sending it this side. Okay, I'm writing it to the left hand side. So minus, this will be 3200 into 10 raised to power 3 d raised to power 2 minus 1.739 into 10 raised to power 11 equals to 0. So this is what I'll get, right? Now from here, if I replace d square is equal to x. Okay, so if I replace d square equals to x, we'll get an equation. Now if we replace it in this manner, we'll get 154 x square, right? So d raised to power 4 here will be square according to this, right? Minus 3200 into 10 raised to power 3 d square is equals to x minus 1.739 into 10 raised to power 3 10 raised to power 11 equals to 0, right? Now from here I can divide this with 154 and even this with 154 and this one with 154. So if I divide by 154 for each value, I'll be getting just x square minus here it will be, the value will be 20779.221 x minus here it will be 1129220779 will be equal to 0. So this is the value that we will be getting if we divide it by 154 for each value here. Now from here it forms a quadratic equation, and if you can directly solve it in a calculator or else solve it in this manner, which will be x equals to minus b plus minus root over of b square minus 4ac divided by 2a. Now from here b is equals to this value here, so minus and minus will be plus, so it will be positive 20779.221 plus minus root over of b square. So I have minus, b is here minus 20779.221 whole square minus 4 into a is, since there is no number in front of x, so consider it as 1. So 1 into c is minus 1129220779. So this is c whole square. This is whole square divided by 2a. So 2 into a is 1. Okay, so from here you will get this value, x will be coming equal to 20779.221 plus minus 70346.71 divided by 2. Okay, now if you will get two values here. We'll be getting two values. So if you take first value equals to 20779.221 minus 70346.71 divided by 2. So with this minus you'll get value in minus 24783.74 mm. So this minus we cannot take this value. Now let us find another value with positive. X equals to 20779.221 plus 70346.71 divided by 2 will give you value equal to 45562.96 mm, right? Now since we said x is equals to d square, so from here x is equal to d square, so d square will be equal to 45562.96, and from here d will be equal to, if I send this root over here, we'll get 45562.96. so from here d will be coming equal to 213.45 mm, right? Now small d, internal diameter d was equal to 0.8 d. Now from here D will be equal to 0.8 times 213.45, which will be equal to 170.76 mm, which approximately you can take 171 mm. So this is the value of D here. Okay, so I hope this numerical is clear. Internal diameter is 171 mm, external diameter D is 213.45 mm. So this is the last numerical for this unit, and I hope it is clear, and with this the whole syllabus for this subject is also over. So thank you very much for attending this session. I hope it helped you to understand this subject. Thank you very much.